सम्पदः शत्रुबुद्धिविनाशाय दीपज्योतिर्नमोऽस्तुते दीपज्योतिर्नमोऽस्तुते शुभं कुरु त्वं कल्याणम् आरोग्यं धनसम्पदः शुभं कुरु त्वं कल्याणम् आरोग्यं धनसम्पदः.
Yeah, Chiranji, we can start. And after your welcome speech, I would like to give the presidential address.
Okay, thank you so much. அனைவருக்கும் அரங்கினில் உள்ள அனைவருக்கும் எனது பணிவான கனிவான மகிழ்வான மதிய வணக்கங்கள். நமது அமைப்போடு இன்றைக்கு அண்ணா பல்கலைக்கழகம் இணைந்து 72வது ஜூம் செயலி நிகழ்வு இனிதே இன்று துவங்கியுள்ளது. இந்த இனிதொரு நிகழ்விலே முப்பெரும் பேராசிரியர் பெருமக்கள் டாக்டர் ஏ சுரேஷ் பாபு, ஹெட் இன்சார்ஜ் டிபார்ட்மெண்ட் ஆஃப் மெக்கானிக்கல் இன்ஜினியரிங் சிஇஜி அண்ணா யூனிவர்சிட்டி அவர்களும், ஸ்ரீமதி டாக்டர் ஜி அருமைக்கண்ணு ப்ரொஃபசர் டிபார்ட்மெண்ட் ஆஃப் மேனுஃபேக்சரிங் இன்ஜினியரிங் அவர்களும், மதிப்பிற்குரிய ஸ்ரீ ஆனந்த் பிரகாசம் கண்ட்ரி ஹெட் இஓஎஸ் இந்தியா ஆபரேஷன் அவர்களும் இங்கே இணைந்துள்ளார்கள். இவர்கள் மூவரையும் லகு உத்யோக் பாரதி சார்பாகவும் என்ஐ குவார் சார்பாகவும் இருகரம் கூப்பி அனைவர் சார்பாக அவையோரில் இருக்கிற அத்தனை பேர் சார்பாகவும் வரவேற்பதில் எல்லையில்லா மகிழ்வுறுகிறேன். இன்றைய நிகழ்வு குறித்து ஒரு சிலவற்றை இங்கே பதிவிட கடமைப்பட்டுள்ளேன். நமது பாரத திருநாட்டில் அடிட்டிவ் மேனுஃபேக்சரிங் சேர்க்கை உற்பத்தி 3D பிரிண்டிங் தொழில்நுட்பங்கள் வேகமான கட்டத்தில் வளர்ந்து வருவது நாம் அனைவரும் அறிந்த ஒன்று. வடிவமைப்பு சுதந்திர டிஜிட்டல் உற்பத்தி, அதாவது டிசைன் ஃப்ரீடம், வெகுஜன தனி பயனாக்கம் மாஸ் கம்யூனிகேஷன் கஸ்டமைசேஷன், செலவு மற்றும் நேரமின்மை காஸ்ட் அண்ட் டைம் மேனேஜ்மெண்ட் போன்றவற்றில் இந்த தொழில்நுட்பத்தால் பயனடையாம் என்பதில் எல்லளவும் சந்தேகமில்லை என்று இந்த அவைதனில் பகிர்ந்திட கடமைப்பட்டுள்ளேன். நாம் அனைவரும் அறிந்த ஒன்றே. செயல்முறைகள் மற்றும் தொழில்நுட்பத்தை புரிந்து கொள்ளும் திறன் இல்லாமையேதான் நம்முடைய பிரச்சனையில் மூல காரணமாக கருதுகிறோம். இந்த தொழில்நுட்பம் பாரம்பரிய உற்பத்தியின் வரம்புகளை கடந்த காலத்திற்கு தள்ளுகிறது என்பதே உண்மை என்று இங்கே தெள்ள தெளிவாக கூறலாம், உறுதியாக சொல்லலாம். இதற்கு தொழிலாளர்கள் மற்றும் பொறியியலாளர்கள் முற்றிலும் மாறுபட்ட பாணியில் செயல்முறைகளை பற்றி சிந்திக்க வேண்டும் என்பதே ஆணித்தரமான உண்மை. இந்த தொழில்நுட்பத்தின் சலுகைகளை அனுபவிக்க நமது தொழிலாளர்கள் சீரமைக்கப்பட வேண்டும் என்பது மறுக்க முடியாத உண்மையாக இங்கே கருதுகிறேன். தொழிற்கல்வி கூட்டாண்மை திறனினுடைய இடைவெளியை இன்றைய நிகழ்வு குறைக்கும் என்பதில் எல்லளவும் யாருக்கும் சந்தேகமில்லை. இந்த இனிதொரு நிகழ்வினில் நான் ஏற்கனவே கூறியது போன்று 3 சிறப்பு பேச்சாளர்கள் இங்கே அமர்ந்திருக்கின்றார்கள். அவர்களை பற்றி இந்த அவைதலில் ஒரு சிலவற்றை கூற நாம் கடமைப்பட்டுள்ளோம். டாக்டர் சுரேஷ் பாபு இஸ் ஒர்க்கிங் as associate professor and currently heading up Department of Manufacturing Engineering. He is also platoon commander of Army Wing, NCC Anna University. He has 55 technical papers published. He is also authored books in the field of manufacturing engineering published by Pearson Education and Oxford University. டாக்டர் ஜி அருமைக்கண்ணு இந்த நிகழ்வினுடைய முக்கியமான பேச்சாளர் என்று கருதலாம். இந்த நிகழ்விற்கு அடித்தளமிட்டவர் இவர்தான். ப்ரொஃபசர் இன் டிபார்ட்மெண்ட் ஆஃப் மேனுஃபேக்சரிங் இன்ஜினியரிங், சேர்மன் ஆஃப் ஃபேக்கல்டி ஆஃப் மெக்கானிக்கல் இன்ஜினியரிங், அண்ணா யூனிவர்சிட்டி. She had completed her BE, ME in production engineering and received her PhD in the area of Anna University only. He is a PhD of area of additive manufacturing in Anna University also. She have more than 100 journals and conference publication and also authored 3 books publications. She has 33 years of experience in teaching and research, 20 years of experience in the field of 3D printing and additive manufacturing. இது மிகவும் சிறப்பு வாய்ந்ததாக கருதுகிறோம். He serves as an expert advertising committee in Anna University, member of DST also. Then third speaker, Mr. Anand Prakasan, he is a country head India உடைய country head. Then he is one of the pioneer in the field of 3D printing in India. He was involved in setting the India's first digital dental lab in Mumbai using 3D printing and was involved in several HAL, ISRO and IAF strategic projects. இந்த முப்பெரும் ஜாம்பவான்களை பற்றி நிகழ்வில் சொல்லியது போன்று இங்கே சிறப்பு வாய்ந்ததாக கருதி இவர்களுடைய சிறப்புமிக்க பேச்சினை நாம் கேட்க ஆவலாக காத்துக் கொண்டிருக்கின்றோம். இந்த அவை மீண்டும் அவர்களை வருக வருக என வரவேற்று அமர்கிறேன். அதற்கு முன் நமது லகு உத்தியோக் பாரதியினுடைய பிசினஸ் டெவலப்மெண்ட் டீம் ஒவ்வொரு நிகழ்விலும் ஒரு 5 முதல் 10 நம்முடைய உறுப்பினர்களுடைய நிறுவனங்களுடைய செயல்பாடுகளை விவரிக்க உள்ளது. I handed over to our business development team convener, Mr. Bangaj Bandari. Bangaj ji, over to you.
Thank you, sir. Namaskar.
Namaskar.
Our business development team for Lagu Udyog Bharati has been drawing phenomenal strength from its mentors, Sri Hariharan ji and Sri Cherian ji. And the team is fantastically supported by our Uma Mayappan ji, Selva Kumar ji, Satish Kumar ji, Vivekanand ji, and very recently, Sri Kadir ji also joined us. The sole motto of our Lagu Udyog Bharati business development is how can we improve the business of our partners, our members. It is a very simple task which we are trying to do. What we are trying to do is every week we select 5 to 6 members of various businesses promoted on a WhatsApp Telegram group, and I'm requesting the business promoters to give a 1-minute video representation so that we can play it on such important program of ours. The idea is not that this 1-minute video is distributed to various members. Of course, that's a very important task. But the more important part is in 1 minute, the business promoter realizes what he has to talk about his business. Yes, I had to push a couple of members. But see, it is very difficult for us to bring anything in a very short form. And if you are able to present your business in 1 minute, just visualize a situation. Tomorrow you're in a flight and somebody sitting next to your flight and somebody says, what are you doing? You have to give him in 30 seconds of 1 minute presentation what you're doing. And you have to give the best of what you're doing, which is your specialty. Because today what is going to sell is our specialty and only our specialty. Markets are going to improve, but the first people who are going to improve his business is our specialty. Today's program organized by Uma Mayappanchi is in that frame of mind. 3D printing for a lot of prototyping. So here I am, dear members, for a series of videos. I look forward to a lot of support in coming days. And I also look forward how we can promote our members on various other forums. Right now, I'm telling you it is video Zoom videos. But very soon we are going to meet one-to-one and you are going to give presentation in 1 minute to all of us. So here's our presentation of our members. Approximately about 10 of our members are there on today's video. Please have a look at them. If you get to connect them to any of your existing customers to their business, would be phenomenal. Or if you can help them set up new processes to reduce the cost, it would be phenomenal. Your experience matters. And today we have a VVIP on this video as well. Just a moment, let me share the video.
Hello, my name is Raja Mohan and I represent IPCOM, a company based out of Coimbatore. We have been selling and servicing computers and laptops for over 25 years now. I am an IT consultant with focus on helping customers optimize their IT setup. IPCOM is also a Google for Cloud partner for over 6 years now, and we are specializing in deploying email solutions for our customers using Gmail and the suite of applications that come with it. As you all know, email is the lifeline of business today, and it is very important to stay organized and to be effective at work. I'll be very happy to provide consultations on email solutions. Your success in business depends on how effectively you use technology to your advantage. I can be reached on 934 5555 663, or you can simply mail me at raj@ipcom.in. I am widely networked with the business community and I am eagerly looking forward to taking your connection request as well. Our tagline is we help you to improve your productivity at work. Looking forward to working with you all. Have a nice day. Bye.
Namaskar. I am Raja Satanathan, LUB Chennai chapter member. I am the founder and principal consultant at Amora Business Solutions Private Limited. We are into market research and business consulting. We provide market research solutions, be it B2B, B2C, and even industry reports. We also provide digital marketing solutions. We take care of your digital online brand presence. Also, we do provide solutions to business in strategizing their growth. Any business ideas need to be nurtured, implemented, and monetized. And we provide solutions that helps businesses to monetize their ideas. Regarding the connect, we'll be able to connect our members in insurance industry and as well as IT software solution industry. And regarding the asks, look out, we are looking for any businesses who are ambitious to grow. They would be our target. So we are here to support companies in realizing their business growth. Thank you. You can reach us at raja@amura.pro, amura.pro. Thank you.
Namaste. I am PR Mohan, proprietor Aroma Hair Springs, Chennai. I am proud of being a part of Lagu Udyog Bharati for the past 10 years. We make hair springs. Hairspring is a assembly. Consists of wire and bush. Hairspring is used in analog instruments. This considers as a heart of an instrument. Accuracy of an instrument depends upon the quality of the hairspring. Larger volume goes into automobile dashboard instruments, pressure gauges, and electrical measuring instruments. There are very few manufacturers of a hairspring worldwide. We can help our LUB members to connect the instrument and their parts manufacturers as well as brass parts manufacturers. Thank you. These are some of the component samples displayed here. This is the speedometer, timepiece, dial thermometer, pressure gauge, electrical measuring instruments, and mechanical measuring instruments.
Humo Media Productions Private Limited. Humo, the creative wizard, wizarding to create infinite possibilities. Cinemavins, innovation in digital era. Experience the magic spells of sound in our scintillating sound studio. Magic Wand. Humo Media Productions Private Limited. An epitome of media excellence.
Vanakkam. I am Lagu Udyog Bharat member. My name is Shantakumar from Adroit Power Systems India Private Limited, Coimbatore. We are into manufacturing and suppliers of servo and static stabilizers, online UPS, isolation transformers, etc. We also do power audit to identify the quality of power by which we can enhance, eliminate the power hazard and power losses occurring in any industries. We are also OEM for servo stabilizers to top brands in Tamil Nadu and Kerala. I can connect our members into government industries, Tirupur, where we have quite a lot of customers. So here I request to connect the industries which are facing frequent electrical breakdowns and the clients looking for energy savings and good quality power to enhance the life of their sophisticated equipments. Thank you again. Shantakumar from Adroit Power, Coimbatore.
Hello, yeah, this is Selvakumar Tirunavukarasu from HDC Power Systems Private Limited. Actually, we are a government contractors and we are not from manufacturing sector but from a MSME service sector. We do a lot of civil, mechanical and electrical projects, and we do it only with PSUs. We have been pioneers in many things in terms of filing a first case in MSME Facilitation Council way back in 2008, and till date having won 4 to 5 cases which were long overdue and long drawn cases from PSUs and state governments. I wish any civil, mechanical, electrical jobs are being referred to us for in-house or for your own customers. We will be very happy to help you. The same way, we will also get back to you for all our requirements, be it goods or services within LUB. This is my pledge. Thank you. Bye.
Enterprises. All types of secured and unsecured bank loans. குறைந்த வட்டியில் எல்லா விதமான வங்கி கடன்கள் விற்றுக்கொள்ள JAF Enterprises. இதில் பார்த்தீங்கன்னா நாங்கள் ஆல்மோஸ்ட் ஒரு 200 crores வரைக்கும் நாங்கள் லோன் அமௌண்ட் டிஸ்போஸ் பண்ணியிருக்கோம். Home loans, business loans, personal loans, loans against property, machinery and equipment loans, new car loans, used car loans, commercial vehicle loans and project funding. No other additional charges, only the banking charges, best interest rates in the industry. மத்திய மாநில அரசின் எல்லா மானியத்துடன் with all subsidies, especially for manufacturing sectors. தமிழக அரசின் டிக் தமிழ்நாடு தொழில் முதலீட்டு கழகம் மற்றும் மத்திய அரசின் சிட்பி அனைத்து விதமான லோன்ஸ் பெற்றுத் தரப்படும். Quick processing, doorstep service. For more details, contact Mr. Anto Magesh, JAF Enterprises, 984-100-9775.
Namaste. This is Hariharan Ramamurthy, Managing Director of Srimukha Group based out of Ambattur, Chennai. I am a very proud member of Lahu Udyog Bharati with the position of All India Vice President. Srimukha Group has 8 manufacturing plants in and around Ambattur estate, and each unit is dedicated to a particular customer. Srimukha Group specializes in the field of auto electrical shafts with a specialty of cold forging, CNC machining, CNC twin spindle machining, sliding head machining, and with a specific expertise in the field of CNC gear hobbing, CNC rack rolling, CNC centerless and cylindrical grinding, and we are approximately manufacture about 100,000 shafts per day to our customers. We are extremely proud of our infrastructure capability, and we would like to associate with any auto OEM in development of some of their critical parts and be a very dedicated vendor and to meet their QCDS requirements. Srimukha Group is now venturing into a program of vendor development, and we have requirement for about 20 CNC machines for development of some of our critical parts which we would like to offload. We request some of the Lahu Udyog Bharati members and other MSME members to get in touch with us for this vendor development program where we can offload a lot of components for development. We once again thank the business development team of Lahu Udyog Bharati for this opportunity and look forward to giving out more support to this team in the near future. Thank you and Jai Hind.
Yeah. Bhagatji, is it over?
Yeah, thank you so much. So I request all our members, help LUB, help the members of LUB to reach more businesses. As somebody so well said, that we know there is darkness out in the business today, but who is stopping us to light the first lamp, to illuminate the light within us and within our community first? Wish you all the best, members. Over to you, sir.
Thank you, Pankajji. It's a fantastic program, I think. ரொம்ப மிகவும் அருமையான முறையில் அனைவரும் ஒரு வியக்கும் வண்ணம் இன்னைக்கு வடிவமைச்சிருக்கீங்க. எல்இபியுடைய வளர்ச்சியில இன்னைக்கு அடுத்த முத்திரையை பதிச்சிட்டு இருக்கீங்க எங்களுடைய பிசினஸ் டெவலப்மெண்ட் டீம். குறிப்பா பார்த்தீங்கன்னா நம்முடைய பங்கஜ் பண்டாரிஜிக்கும் நம்ம உமா மையப்பன்ஜிக்கும் மகிழ்வான மிகப்பெரிய ஒரு நன்றி கலந்த வணக்கத்தின இந்த நல்ல நேரத்தில் அவை முன்னில பகிர்ந்துகிற கடமைப்பட்டிருக்கின்றேன். அடுத்து பார்த்தீங்கன்னா இந்த ஜூம் நிகழ்விற்கு அடித்தளமிட்டு எங்களின் ஊக்கநாயகனாக தொடர்ந்து திகழ்கின்ற எங்களுடைய அமைப்பினுடைய செயல் என்னும் சொல்லுக்கு செம்மலராய் திகழ்கின்ற எங்கள் பாசத்திற்குரிய சகோதரர் தேசிய துணைத் தலைவர் திரு ஹரிஹரன் ராமமூர்த்தி அவர்களை இந்த நிகழ்வினை தலைமையுரையாற்றிடவும் தொடக்கி வைக்கவும் அன்போடு அனைவர் சார்பாகவும் வேண்டுகின்றேன். நன்றி, வணக்கம்.
Yeah, thank you, Sharianji, for the wonderful introduction, welcome address, and dear all, a very hearty welcome to all of you. First of all, I would like to place our heartfelt congratulations to our business development team led by Pankaj Bandari. As Charianji put it, you have really set a big task taken on your shoulders, and you're really doing a wonderful job, I would say. I think this is really going to create a lot of business within the LUB community. And I'm sure that I request all the members to kindly support this initiative, for our own inclusive growth. Having said that, I don't want to take too much of our time, because we have a lot of speakers from the very, very informative session that we have had today. I think this is a very, very important session for our MSME community as such, because as a manufacturer, we ourselves are spending a lot of time on doing a lot of prototypes. And if there is something which is new available in the market, especially the additive technology and the 3D printing, and if we can complete all our prototypes in that, I think that is going to be a big path-breaking solution for all our MSME members. I'm really glad that Lahu Udyog Bharati is doing this such kind of technology initiatives also, and it's really going to pave way for future programs in our LUB. So thank you so much, and let's please hand over the stage to our speakers. First of all, I would like to welcome all the three speakers, through Arumekandu Madam, through Suresh Babuji, and also from EOS GmbH, Germany. So I really thank you for giving us this opportunity to host you. So over to you, over to Charianji. Please take it forward. Thank you. I think Arumekandu Madam, you can probably start.
Yes,
Yeah, madam. Yeah, please start, madam.
Yeah.
Thank you so much, madam.
Namaskaram to everyone.
Yes,
இன்று எங்கள் துறையின் முக்கியமான நிகழ்வு சிறப்பாக இனிதாக திரு செழியன் அவர்களின் மிக தெளிவான அறிமுக உரையோடு ஆரம்பித்துள்ளது. I express my sincere gratitude to all the members of club, especially Madam Uma Madam and Chedian sir. Now I am going to hand over the thing to Anand sir. Anand sir.
Good morning.
First, Anand sir is going to present, and we will join along with the discussion. Then we will going to finish our thing with the vote of thanks by our HOD, Professor Suresh Babu. Okay. Anand sir.
Yes. Good morning to all of you. Thank you, madam, for the handing over to me. Thank you, everyone, for inviting me for this session. I was really impressed with the way this platform is organized.
Sir, you share your screen, sir, then you start.
Yeah, okay. Are you able to see my screen?
No, not it.
Yeah, please come in, sir.
Now it's visible.
Yeah. Thank you. Thank you once again, and very good morning to all of you. I was very impressed by the way this platform is organized. And I hope the next few minutes when I'm sharing this technology to you, it can trigger some ideas into your own businesses, because 3D printing or additive manufacturing is considered as one of those technologies which can support various types of industries. Maybe some of the examples I show here today, or the business cases I show here today, might trigger some ideas to you. So kindly spend some time to look into it. And I'm just trying to, sorry, just the slide is not moving. Yeah, okay. So are you still able to see my screen?
Yes, sir, we are able to see.
Please go ahead.
Yeah, I'm just having some problem on the slide change. So additive manufacturing is a generative process, as you see here. So basically, this is just the opposite of a CNC process, where you have a block of metal and then you remove the metal to form the shape. In additive manufacturing or 3D printing, you start from a zero position and then you generate the complete component or your design. So that's something which is very interesting to note. And the whole process of additive manufacturing starts from a digital data. So the digital data can be in the form of a design data in CAD, or for medical, it can be a CT or a MRI scan data. And this data is usually in the form of .stl, and then this is sliced into layers. For example, if you have a large component, you slice them in 2D sections, and then you start printing them one section at a time, one 2D section at a time. And in the end, you have a complete part printed. And if you see here, the raw material usually is in the form of powder. So powders can be metal powders or polymer powders. And then these powders are put into a machine. And then the laser energy prints layer after layer. And then you're able to form the complete part as it is here, as you can see on the right side. So that's how 3D printing works. It's a generative process. It grows from zero to a complete component, and then you can do different types of designs, or any industries can adapt them. And I like to use this slide from McKinsey, where they talk 3D printing as one of those technologies which will disrupt the way manufacturing industries will adapt them. Today, we all know that 3D printing is used for prototyping. Well, for the last 30 years, they've been used for prototyping. But in the last 5 to 7 years, this technology has been used extensively in manufacturing. And today's presentation, we will see those areas where it's been used in manufacturing and what value it can bring to the industries as such. So what are the key values? For example, I have listed a few of them in this slide. If you see on the left side, we talk about freedom of design, which is lightweighting. You can actually define the weight of the part which you want to manufacture. There's no other process in where you can define the actual weight. So here you have the ability to get the exact weight what you want on the part. So this is a lot of advantage for industries which are in transportation or in aerospace industry. Again, the second big advantage on the cost side is you can integrate functions. From many parts, it can go as one single part. So that integration is possible. Another big advantage is because you're able to print the component directly, you don't need any tooling. So without a mold, you can directly manufacture parts. And then this means you have a very short lead time. So this is another big advantage which many industries would be quite keen on. And if you go into the customization part, in 3D printing, there is no batch size. You don't need a specific volume for it to be effective. Even one part can be viable. And this also gives a lot of opportunities on customization and also on spare parts. And last, but we're talking about time-related activities. Of course, it can be used for fast prototyping. So these are some of the areas which we feel 3D printing definitely has been giving advantages to the industries. And definitely when we talk about advantages, see, it's not another machine or anything like that. It's a manufacturing process. And this manufacturing process provides a technical and a business value. There has to be a value addition by using this manufacturing process. And this value addition should be either a price advantage or it should be an exceptional service. For example, if the standard manufacturing process you're able to deliver, let's say 10 weeks or 12 weeks, and with this manufacturing process, you're able to deliver in 1 week, that's exceptional service to your customers. Third is innovation. Now we are looking at not how to manufacture a part, but what sort of value can you create to your customers. So definitely 3D printing can be only successful if you are able to create a technical or a business value to your customers. Many a time there is a lot of discussion about 3D printing and people are not able to develop this value. They just try to say, okay, I have a part which is manufactured by casting or forging or machining. I just take this part and try to do 3D printing. In that way, you add no value. It's not a substitution. It's a value addition. So this is very important to understand. Unless we create value, this technology is not going to be of huge benefit to you. Now, I want to show you some of the industries which has created value using this technology, and that's why they have adapted it. So first, I take it from a global example, what sort of value addition they are able to bring. If you see here, this is an antenna which goes into a satellite. The original design looks as you see in the left side. It's like that, pretty bulky and other things. But basically, what they need is a design like that, where they are able to reduce a lot of materials. And you can see in this slide, you're able to reduce your weight from 1,626 grams to 936 grams. So the value addition here is weight saving, typically. And this is always a huge topic whenever we have transportation, whether it is car or whether it is airplane or whether it is a space shuttle. Weight is a very important discussion, because with weight, when you save weight, you save energy, you save costs, you save fuel, and you also pollute less the atmosphere. So this is a very important value addition. Second, how many parts into one single part. This is an example from a rocket engine. It's a fuel injector head. Originally, these all are 248 components, each of them individually fixed onto the plate. But today, with 3D printing, you're able to have them as one single component. And you can see cost efficiency, 50% lower cost. So here the value addition is consolidation, part consolidation. You can see here in this slide, this is typically, a part of a special purpose machinery. In here, it has about 20 different parts. It's a very simple part. There are some pipes running inside, and there are some wires here. Now, this whole design has been 3D printed in a different way, where it's only two parts, the plastic part and this rubber. So from a cost perspective, it's very beneficial. And also, all these machineries needs to be serviced. From a service perspective also, it's very easy to open it up. So we have to look at what value creation are you providing with this technology. So this is a value creation which you see here. And the requirement here is about 500 to 1,000 per year. Typically, this is a special purpose machine, as I mentioned to you, a part. And they sell anywhere between 500 numbers to 1,000 numbers. So why didn't they go into plastic? Because in plastic, if they want to use it, they have to make a mold. But here, instead of a mold, they can directly print this component. And this component has 20, if you otherwise there's 20 different assemblies put into one single part, typically. So that's a big value addition again 3D printing can bring to the table. This is a polymer again. And again, as you see here, we are talking about how much can you print roughly. This is a connector, typically an automotive connector or electrical connector. And we're talking about 11,000 of them printed in a week's time without any mold. So you can see the sort of productivity which you can bring. And again, if you see here, there's a turbocharger housing. You're talking about 135 in about 4 days, 4 to 5 days typically. No tooling, no mold. So also it helps like when you're starting a new product line, you don't want to put a lot of capital costs in your molds and tools. You can directly start map printing them and supplying it into the market. Even you can do a market study, seeing how viable are these parts. So there's a lot of advantage which 3D printing is bringing, and we have to really look where the advantage is. There's no merits in printing what you have exactly as it is. And this is an example from an automotive company, Mini Cooper. We know this brand. And typically what they are doing is they are providing customized dashboards, which you can fit it directly onto the Mini, for example. And you can see you can have your name, you can put your color. And the advantage here is you can select this online, and then in a week's time, they are having a delivery. So there is no inventory needed for Mini. Basically, all these inventories are in the form of digital data. And tomorrow you don't like red color, you can order a blue color like that. And then you can put it on the dashboard. So just giving you the different concepts, how 3D printing can create value for your customers as it is. For example, here you can see the name of the customer also put on the dashboard. So these type of personalization creates a certain value again among the brand as it is. And when we talk about personalization and one-off parts, spare parts become a very interesting topic. Daimler-Benz, they went through a lot of inventory parts which they had, spare parts for the last 15 years. And they said, there's a lot of inventory which we need to carry. And again, a lot of legacy parts are there. So how can we make it more cost effective? So they did a lot of study, and then finally, from a list of close to 10,000 parts, they were able to identify more than 380 parts which can be used by 3D printing, which means these parts have technical advantage or technical viability, and they also have a cost viability. So today, for more than 380 of these components, there are no inventories. There are only digital data. So it's a digital inventory. And they save millions and millions of dollars every month by doing these type of things. So from a physical inventory to a digital inventory. Again, you can see there is a value addition which 3D printing can provide. And also why I show this aircraft industry is 3D printing has been used in most demanding environments, right from aero engines to different components inside an aircraft part. This is a part in a fighter aircraft. So there are a lot of parts which can be 3D printed. And again, the weight becomes a very important element here. And if you go into industrial applications, we are talking about robotics. Again, you see these arms, robotic arms. So typically your components can change shapes. So as per the shape, you can quickly 3D print the arm. And this is an example from Festo. It's a bionic design. And this helps in quick changeover of your automation production area again. Pick and place. For example, if you see in different automotive industries, in paint shops and other things, you need pick and place mechanisms. So based on components, you can quickly define that arm definition and manufacture them. And again, it's toolless, no need for any tooling. And again, when we talk about spare parts continuation, we talk about gas turbine industry. This is an example from Siemens, where they talk about the burners. This is the burner, the person who's holding in his hand. So these burners typically wear out after a period of time, and these burners needs to be sent back, and then they sort of machine off a large area of the burner, and then they completely rebuild that burner. So in today, what they do is they just turn off only a few millimeters on top where the burner is worn out, and then they put this burner inside the 3D printer and then manufacture only those areas which are worn out on top of the burner. So by this, what Siemens mentions to us is from 44 weeks lead time, they are able to bring it to 4 weeks lead time in terms of repair applications. So here again, it's a lead time and a value addition which you are offering to your customers again. Now let's look into some of the value additions from Sorry, is there a question? Okay. So let's look into the business transformation in India. So far we've seen from a global perspective. Let's look at from an Indian perspective how it's able to create value. So in India, if you look at it, the first part which flew into space. Sorry, is there a question? Okay.
ஒரு PKS எடுப்பாரா சின்ன மிஷின் வச்சிருக்காருல
Shirin sir, please mic have to be switched off.
Yeah, thank you very much. So again, we talk from an Indian perspective. This is a part which flies in our rockets. It's a GSAT in GSAT 19. It's a communication part. Basically, it's called the feed horn. So originally these parts are like cones, and they are welded together, and then they are sent to space. So the challenge they've been having is there is always this RF leakages which happens in the welding joints, because there are some problems which they face. So right now, what they do is all these 4 cones are integrated together and they are printed as one single part. And ISRO told us that they have no leakages today as such, and this part is still in the orbit. So that's again a sort of a value creation, because we were able to arrest the RF leakages, and then the weight again is reduced in this component. From an aerospace perspective, this is a fuel elbow for a Sukhoi 30 aircraft, where this is spare part. Original part is from Russia, but due to whatever reasons, long lead times and difficult purchasing mechanisms, they were not able to get this fuel elbow. Now these parts need to be certified by Semilac, which is an Indian FAA, and these parts were 3D printed and has passed through all the certification process needed by the fighter aircraft industry. And then we also talk about medical, by which I will show you in another slide. So today, 3D printing is not only used in industries as it is, but also helps patients. For example, you see here, this is a slide from CSIR lab, CSIO in Chandigarh, where they work with AIMS. You can see this is an implant, which is put into a customized implant. Based on the patient's requirement, it's made out of titanium, it's put onto the patients. And the quality of the patient's life improves drastically. I mean, his surgery time reduces because the doctor don't have to cut too many bones. The surgery time is shorter, the anesthesia time is shorter, his recovery time is much faster, and the quality of life definitely improves by having these type of stuffs. Again, you can see another example. This is again acetabulum cup, patient-specific implant. Here you can see. So they have a CT scan and change from CAD, and then they design the implant, and then they put this implant in the region as such. And you can see pre-operative X-rays, and after the, again, this is a patient-specific one printed out of titanium. Again, we're talking about value addition to the patient as such. Value addition in terms of surgery, patient life quality, and the recovery is also very good. Again, this is a mandible. You can see here, this is defined here. Today, we have a big population which uses a lot of tobacco, and then also from cancer. It can go away in different directions. So you have to exactly define the right spot. Sometimes the standard implants are large, medium, small, large, or extra large. So we cannot use them. If we use them, we have to cut out too many portions here. But here with additive manufacturing or 3D printing, we are able to provide very, a sort of perfect to the patient, and he doesn't lose more of his bones, and it gives him a better quality life again here. So all those examples what I'm showing here are currently being used in the industry, and they all of them are either solving a problem or creating a specific value to the end customers. So that's how 3D printing has to be perceived. It should never be perceived as another machine which is used for producing any parts as such. And of course, this is an example from Tool and Die. This is a project from Salcom in Chennai. So you can see this is the Nokia chargers as such. And when we go there, so again, when you talk about die and mold, we talk about the die life and how well we can cool the molds. So you can see here, this is a standard insert, which is used for cooling. But with 3D printing, we can make 3D cooling lines like this, which means the surface area of the cooling increases more, and the plastic can be cooled more efficiently and faster. So when you cool the plastic more efficiently and faster, we are able to save a lot of time during production. And you can see here, the standard cooling by normal methodology, the production time is about, or the cooling time is about 14 seconds. So you see here, the cooling with 3D cooling is about 8 seconds. And this is a mass production tool. So you can imagine the amount of money one can save, the amount of capacity one can save, and can be very cost effective in these things. So whether it's a direct part in metal, whether it's a direct part in plastic, whether it's a mold or die, there has to be a value creation. The value creation either could be in terms of cost or in service like lead time or better lifetime of the patients, or it can be innovation, as we can look through. Now, when we talk about all these big advantages, which you have seen all my examples across industries. We talked about aerospace, we talked about space, we talked about automotive, we talked about medical, machine tool, we talked about turbo machinery, heavy engineering. But when it's addressing the value creation in so many industries, where are the challenges? Because if you look into India, you don't see a huge adoption of AM still. People are starting, but people still think it's only for prototyping. And where are the challenges? Because this is another manufacturing process. So we made a survey or we made a study or a sort of a session with more than 500 companies. And we found that a huge amount of people, the biggest challenge in AM or 3D printing implementation is the lack of knowledge. Typically, they are not clear that what this technology can do for them. Yes, they have heard it in internet, they have heard it in seminars, they have studied something or read something, but they really don't know what this technology can do for them. And again, a lot of them tell me that we are not able to define a business case. I am in a particular industry. I don't know how 3D printing can, for example, do, let's say I'm from a forging industry. I don't know what 3D printing can do for me. I only know it as a prototyping tool. I don't have a business case. How can I move forward? And this all comes from the lack of experience, because we don't study 3D printing as a manufacturing process in engineering or in any other institutes. We probably, some of them have 3D printing curriculum, but that's very basic from a point of what is 3D printing and all those things. So this lack of knowledge is which hinders our big nation to grow in this process. So now what is this, what to learn basically? What is it, why do you say it's a lack of knowledge? What is it there to learn? So the first important thing is 3D printing is another manufacturing technology, as I mentioned to you. Not all components are the right candidates for 3D printing. So you have to really understand which parts, for example, you see here, this is an automotive part. There are hundreds and hundreds of parts. We have to understand which type of parts are suitable technically, metallurgically, and from an economic perspective, suitable for metal 3D printing. We know today what parts are good for casting. We know today what parts are good for forging from this list, but we don't know what parts are good for 3D printing. This is a big gap. I mean, I can tell you that, I've been with 3D printing for the last 23 years with EOS, and I've seen that in a country of 1.2 billion people, it's less than 100 people who know how to really look for these parts. So that's a huge knowledge gap. Skill development is needed. So this is the first thing, which is a big stumbling block. You can put any industry, you can put any picture here. You can put an aircraft picture, you can put a turbo machinery picture, you can put a washing machine picture, you can put any picture here and have all those parts. The first step itself, we are not able to define clearly. And that's one of the big reasons why we are not able to define a clear business case, number one. Number two is, I talked about value creation. We have to create a value, whether it's weight or functional integration or anything. So the value can be created only from the design data. Today, I've taken an example of a bicycle pedal. This is a normal pedal, whether it's a motorbike or a cycle. If you directly print them in 3D printing, you really gain nothing out of it, basically, because you're not creating any value. Why should you take from this side, from a CNC here, and 3D print them? There's no value. You don't save weight. You don't have any specific aesthetic look or anything like that. So unless you are able to create a certain value like this, as you see here, and able to reduce weight or cost, then there is an effect which you can pass it on to the customers. So again, how to design for 3D printing, how to design and create value using 3D printing is also a very big topic which industries are not aware of. So this is again a large knowledge gap which is pending in the market again. And likewise, there are many areas where training and learning has to be introduced. It can start from the basic, as you see here, fundamentals, what materials, which are the right materials to 3D print, part screening, design, lattice structure, going up to the certification, how to certify parts which are printed in 3D printing. What standard should I use? Should I use ASTM standard, ISO standard? Are there standards? So these are things, which people are not exposed to. And I think it's important for people to learn these things. And as engineers, it's very interesting because only when you learn, you have the confidence to implement it. Important question is where to learn. So what we are having now is this Additive Minds group, which provides this learning. And we've been discussing and trying to provide this through the Additive Manufacturing Lab at Anna University. And we are trying to consolidate all this into a single program, as you can see. But before I say that, I want to show this slide, because what is the process chain of 3D printing? You have your idea or your CAD file or any data, digital, and then you print. And then this LO1 is post-processing. But the biggest knowledge which somebody needs to gain is not on how to use the machine, but how to really develop the digital tools. For example, I talked about how to select the right parts, how to design, how to develop business case. So we are talking about a lot of learning on the digital side of this manufacturing process. And we were trying to look at it and we say it's up to 60% of the learning is on the digital side. It's not on how you operate the machine. That's very simple, very straightforward. But still, there are some things to learn, but we would contribute only about 25% of it. So this 60% learning is what we are trying to see how we can upskill both the academia as well as the MSMEs, because the MSMEs form a very strong backbone of the industry. And unless they are able to implement it, and for them to implement, it should not be a cool thing. It should be something which could bring them a sort of a value which they are able to show to the OEMs, or it should bring certain sort of revenue to them. And that's very important. And that's where we feel this learning is very important to start with. And when we talk, so we have created this industry AM readiness program where we're talking about topics like technology, typically there are many types of technology. So you need to understand which type is for what. Again, what materials. And again, 3D, no technology is perfect. Every technology has a technology boundary, a barrier, which we need to understand. And if the industry understands it, they can definitely see where it can go forward to. And again, post-processing, what sort of, whether you have to do heat treatment or any other process after printing. So these are the main topics again. It's one module. The second module is how to select the right parts for 3D printing. So when we talk about part selection, I showed you one example of a car's exploded view of different things. So whichever industry you're in, you need to understand which of your industrial parts are good for 3D printing. So this is also another module. I mean, you may be in industry last 10 years, so you might be having more than several hundred parts in your list. So we have to see which of them and how to really create a digital library for your spare parts. This is also very interesting to do look at it. And this third module is on value creation. So how to create value with designs. Because if there's no value, then basically we are not talking about a very robust business situation. So what value are you able to create to your customers with 3D printing for your industry? Again, this is another module of the training. And with all these things, how to really define a business case? How much utilization would you expect to have with 3D printing? And what sort of ROI can you look at it? So these are the 4 core topics which I think would help any engineers or any managers or business owners based on which module is interesting for you to take it to your company to the next level. And again, no technology, no industry can work if it doesn't have the right people. So again, most important thing is what sort of organization structure and infrastructure you have. So that's a report which we also would like to add as a part of this training. And optionally, we also feel that during your learning, it would be nice if we could take one of your parts and show what value we can do and print that part and provide it to you. So that would also create a huge amount of confidence among your team as well. So that's something which we call the industry's AM readiness program, which we're talking about. So this syllabus are very clear. It's with Dr. Armek and Madam as well. So we can really show how in different areas, different modules we are talking about, how to enable your people. So I think if we are able to provide such a learning to the team, I think we can create products which, you cannot perceive manufacturing in any other way. I mean, look at these parts. It's all printed in one piece. It cannot be manufactured in one single way. And if we are able to make these things like that, then what we can do is we definitely can move away from huge factories, huge investments like this to a very lean manufacturing chain where there is a digital data and there is a printer and there is a component coming out. Because today the world needs a lot of agility. We also call this as agile manufacturing because such a printing production process, if you have a printer like that, it's not defined for medical or it's not defined for aerospace. It's generic. You can use it today for medical, tomorrow for automotive, tomorrow for anything. All that changes here is only on the digital side. So the software or the design, what you do, if it's for medical, it's for medical. So you can define it like that. So it gives you a very lean and agile manufacturing setup. And the turnaround times are much faster. The factories can be much smaller. And the people needed are more on upskilled people, than the traditional people which we're talking about. And if you're going to do that, we foresee that these type of digital setups would come in. Please do not, I know all of us know the importance of digitalization, but I want to show one more slide which shows how impactful it has been. For example, you see this. These are the large industries, the top 5 of them globally from market cap. You see, in up to 2011, we are talking about these large companies, petrochemical, all these type of companies. But from 2017, you can see these companies, Apple, Alphabet, Microsoft, Amazon, Facebook. All these companies have one thing in common. They are digital. They are digital. So if you are able to make your organization agile, lean, flexible, and digital, and create a value to your customers, I think we can be considered as one of the leaders in this advanced manufacturing field. So with this short background, I thank you for your time, and any further questions, you can always reach out to the Additive Manufacturing Lab in Anna University, and I'm open for questions now. Thank you once again.
Thank you, Anand sir.
Yeah.
Yeah. Madam, you wanted to speak anything?
If any questions are there, then we are able to have discussion on to the topics, on the questions. I think we have one question on the chat box.
Yes, yes. Mr. Asen is asking. You can read, madam.
Yeah, that is one. Mr. Hussain sir, you have one question, no? That's a 3D printing. That is the question is, this is a question from Hussain from Tech Plastic Industries, Chennai. The question is, we are into plastic injection molding. In 3D printer tooling, we wanted to know how to clean the cooling channels when they get blocked. For conventional tools, it is easier for Agile to reach, but how would it work for 3D printer tooling? 3D printer tooling.
Yeah. So we know this question. Hello. Yeah, we know this question has been coming from many tool makers. How to really, because the water quality which we use is very bad. So there are two options which is available. One is either they can go for RO based water for cooling. The second option is there is an abrasive clean mechanism which works under pressure, which is available. It's a product from Germany. So this helps in managing your cooling channels much better. But if you have, please drop in your email address on the chat box. I will forward the data to you by email later.
Sir, another question is, it is from Hariharan. It is from Hariharan from Engineering College. The question is, can we able to improve the strength of the material after printing in post-processing techniques, multi-jet fusion technology and fused deposition modeling technology?
So let me understand the question. When you talk about can we improve the strength of materials, I'm speaking with related to powder bed. When it's metal, yes, you can increase the strength by sort of heat treatment cycles a little bit more. For example, the insert which you print in tooling, directly from the process, you get about 34 to 35 Rockwell. And when you do a sort of age hardening process by heat treatment, you get up to 52 Rockwell C. So that in that way, you are able to increase the hardness. You can increase post, your properties also by heat treatment. So this is possible. I did not understand the question on fuse deposition and multi-jet.
Multi-jet fusion technology also you can able to improve the mechanical property. It is possible to some extent. Fused deposition modeling technology, it is for which application and how much you want to increase. Based on that, we can able to.
Yeah, I guess you're talking about using a wire metal in a fused deposition machine. Yes, once you print the part, I think you have a few heat treatment procedures. But again, these procedures has to be as per some standards, and the heat treatment cycle curves have to be clearly defined. So this is also a part of the learning which you must understand.
Yeah, but I do not know whether he's on wire metal or it may be a fused deposition of plastics.
Plastics, I don't know. Do you know, ma'am? Yeah. Plastics can
metal
increase.
We can able to do it.
Metal we can increase. Plastics, no.
Okay. Then again, the question is from Hussain sir. Would like to know the different grades of materials available for injection molding. We currently use RVAR Supreme for hard tools and P20 for soft tools. Can 3D printed materials match the same hardness and life?
Yeah. So for injection molding, we recommend Maraging steel, which is an age hardening tool steel. it's 1.2709 tool steel. And for die casting, we recommend H13 tool steel. So both are available in powder form. You can use them. And also we have a particular type of tool steel which is corrosion resistant. It's called Corax. So this is also possible. All the three types of steels based on what application you need.
So the another question is from Mr. V.S. Jagadishan. Sir, it's very informative presentation. I am Jagadishan, Jason Industries, Salem. I would like to know at what tolerance we can achieve in 3D printing.
Let me speak from a metal perspective. I think you're looking more from the metal side. I think as printed, it's possible to go somewhere around 50 microns tolerance limit. It's also possible in some areas to get lower than that. But since it's a layer by layer manufacturing process, the orientation matters a lot. So depending on which tolerance limits are more important to you, we can orient it in that fashion, and then we can create the tolerances in the right direction. But in general, we say about 50 microns around the bed, part volume. If you need a much tighter tolerance, then we ask you to give a little bit of stock and then machine it to the final dimensions. So that's also possible.
Different materials. That is a question I answered. So is there any questions?
Anyone wants to
I
talk
also wanted
directly?
to add,
Yeah, anyone wants to talk directly, you can raise your hand. I can unmute it.
There are other questions in chat box. You can look at about the materials, different materials has been used for tool. It is there. What materials can be 3D manufactured? One question is there.
yes, what are the post-processing machining technologies is done with DMLS, DPM printed parts?
So when we talk about I think there are two questions. One is the material. So most of the weldable materials can be 3D printed. But what I mean is any types of steels, tool steel, stainless steel, aluminum, Inconel, nickel superalloys, titanium. We're talking about cobalt chrome, tantalum, molybdenum, tungsten. So a lot of these are can be 3D printed. And the second is definitely when we talk about post-processing, the 3D printed part exactly is like a welded part. So you can do any type of post-processing, post-machining, you can do stress relieving, you can do heat treatment, you can do all sorts of polishing to a mirror finish. So all what you would do on a standard metal part you can do. So there is no restrictions as it is.
Yeah, Ravan sir, you can talk, sir. I unmute you.
Sir, thank you. Sir, answer, I have a query. Suppose somebody wants we have a very old machine which is I think imported 30 years back, and they want a part to be made, a gear to be made. Can you 3D print the gear alone, the top portion of the gear portion alone, and just fit it onto a shaft and just reuse it? Will that be work with 3D printing?
Yes.
See, there are certain types of gear steels which we use to manufacture this, but we will not be able to make the final finished gear as it is. We will be able to go to a near net shape on a gear, and then we have to do the final hobbing operation on the gear.
This looks like very interesting with respect to spare parts, like what you rightly mentioned.
Yeah.
Extremely interesting with respect to machinery suppliers. I think they'll find it very interesting.
Absolutely.
Or those who are because this is fascinating to even understand. Thanks a lot.
Yep.
Thank you very much, sir. Thank you very much, sir. If at all, if there is any question, I wanted to add one more thing, and above all, there are many things to add actually, especially for the tooling industry. You can think this 3D printing as a replacement for metal for a certain application. Especially many parts are currently machined from metal simply because this has traditionally been easiest way to make them, not because they must be made of metal. So the plastic 3D printed parts can also be a valid replacement for components made of metal. That way also you can think, especially for the tooling industries, low volume production.
Yeah.
Is there any question about that?
Yeah, I have a question.
Yes, sir. Yes, sir.
It was really a wonderful presentation. I've really jotted down a lot of points, but I had another call in between, so I just was not able to go through it. I will definitely go through it after. We have a YouTube video also being recording for this particular session. I have only one question. We have discussed a lot about the satellite antenna brackets and a lot of these fuel injector heads and some metal to plastic conversion and all that. How does the 3D printing ensure the performance of such products? Uh, uh, when you try to convince the customer that we have to go from such one product to another product, how does 3D printing ensure the performance of the product?
So just to understand your question, when you say performance from a mechanical property, are you talking about?
Mechanical properties.
Okay. So typically, a part 3D printed meets a certain amount of mechanical property data as per either ASTM, DIN, or ISO standards. So when you look at the microstructure of the part, in the metal, you can see it is very, very close to casted or just above the casted area, the wrought area. So typically any parts which are around the rod area, those mechanical properties we can definitely address. But when we want to go into the forged area, then we have to do something like hipping, which will help us to go into the hipped data typically. So all these 3D printed materials which are used, there is a lot of mechanical data sheet available as built conditions, as heat treated, as per this standard, another standard. And we can show all these data to the customers. And typically what aerospace companies do is, because these parts, you have to also remember, are used in aircraft engines. So typically that's the ultimate test for any of these parts. And when they print a part, they also print some test coupons along with the part. So they can also do some destructive testings and really find if these parts are matching it. So there is a lot of data available, but in some industries, maybe we don't have enough data, but we can print test coupons and do validation of that data.
Okay. Thank you, sir. Thank you so much. Chayanji?
IST. Now I request Dr. Suresh Babu, Head of the Department of Manufacturing Engineering, Anna University, to give his special address. Actually, he's
Thank you, sir.
He's a platoon commander of Army Wing. ஒரு தேசபக்தி மிக்கவர்னு சொல்றாங்க. Sir, you go ahead, sir. NCC Anna University NCC உடைய கமாண்டரா இருக்காங்க. You go ahead, sir.
Yes. Please, sir. Please. Thank you very much. So this is Suresh Babu from Department of Manufacturing Engineering.
Sir, உங்க வீடியோ கொஞ்சம் ஆன் பண்ணிக்கங்க சார். Sir, please switch on your video. Our team wants to see your face.
Yes.
Yeah, thank you, sir. Thank you.
I thank for the opportunity given, which is really I have to thank Dr. V.S. Killian, President, and Mrs. Uma Mayappan, EC member, and Mr. P.S. Ramesh of past President, AIMA. Through him only we have approached you to organize this program. And I want to thank Mr. Anand for the wonderful presentation for addressing most of the questions which have been asked by the participants. As far as the program, why it has been organized is concerned, I have to remember that when I was appointed as a Deputy Director in the Center for Technology Development and Transfer, I was assigned the job of in charge for Vision 2023 in the Technology Development and Transfer, in which I still remember there was an enabling condition in which it has mentioned that an economic and institutional regime that incentives creation of new knowledge and entrepreneurship to use that knowledge. This is what has been constituted with a 9% growth rate in Tamil Nadu, which is a target of 11% in 2023. Fortunately, we have crossed that growth rate. Now we are 13%. And sector-wise, if you look at manufacturing, is having the highest growth rate in that 34% after services. Even now I feel that it is not, we have to go a long way in the path of growth, in the growth of the nation. Some of the factors which was mentioned, I happened to read the article in Ministry of Micro, Small and Medium Enterprises, in which it has been mentioned that there are factors which hinder this development, because the MSME is the real contributors for the growth of the nation, in which it has been mentioned that they hesitate to adopt new technology just because of lack of understanding the new knowledge which has been created, and selection of correct technology for their application. And in addition to that, they thought that even if you go for these new technologies, there were lack of skilled manpower, and they don't want to invest made huge investment on equipment. But you can look at today that the government of India and government of Tamil Nadu, they came forward and create facilities in academic institutions. Recently, we have submitted a proposal to the government of India. You can see that it is of 125 crores, very huge amount government is going to spend on creating facilities in academic institutions. These facilities are specifically for using by the MSMEs. This is the target is the 80% of the time the facilities are created in these academic institutions have to be utilized by the MSMEs. So these the points with which the hesitation comes is the capital investment is high. That need not worry about that. The investment is made by the government, and merely can be a replacer of those technologies which are just because of cost factor, you need not to go away from those technologies. So this is what the communications we wanted to make through this program. So need not to hesitate to use latest technology. We are here. There were knowledge pool which has been created in academic institutions that can be very well utilized for your purposes. Even you can scrap your R&D and you can give it to us, and we can work for you, and you need not spend much of time on that. You can be in the process of creating the wellness for the nation. And once again, I wanted to thank the LUB and the UOS, GMPH, Mr. Anand, for coming forward to create this facility at the university, so that we can be able to provide the solutions for the problems of industries. In addition to that, I welcome every one of you to come to the department. There are facilities, not only in our department, in other departments of university. You can find wonderful facilities are available. You can make use of it. The price which cannot be comparable with industry. So at least price, and the services which are offered by us, they can cost wise it will be cheaper. I thank you very much once again. Jay.
Thank you so much, Dr. Sir, for your excellent and fantastic special speech. Now our special and sincere thanks to our EC member, Sri P.S. Ramesh Ji, for his fantastic introduction of this team. இது உண்மையிலேயே ரொம்ப அருமையான ஒரு நிகழ்வாக இன்னைக்கு அமைஞ்சிருக்கு. ரமேஷ் சிக்கு மீண்டும் ஒரு முறை என்னுடைய மனமார்ந்த நன்றிகளும் வாழ்த்துதலும் எல்இபி சார்பாக வழங்குகின்றோம். அடுத்து ஃபைனலா பாத்தீங்கன்னா என்ஐகாருடைய நம்முடைய நேஷனல் ட்ரெஷரர் திரு ராகவன்ஜி அவர்களை முடிவுரை கன்க்ளூடட் ஸ்பீச் தருமாறு அன்போடு வேண்டுகிறேன். ராகவன்ஜி, யூ ப்ளீஸ் கோ அஹெட். Raghavan sir.
Sir, Sedian sir, if time
unmute,
is there.
Yeah. Raghavan sir, இப்ப நீங்க பேசலாம், அன்மியூட் பண்ணிட்டேன். யா மேடம், நீங்க சொல்லுங்க, ஏதோ சொல்ல வந்தீங்க.
இல்ல, யாரோ ஒரு மிஸ்டர் பிரமோத்னு ஒருத்தர்.
யா,
please go to the question ma'am.
Yeah, promote the questions பேசலாம் மேடம்.
Yeah, இல்ல, he didn't make the question. இவங்க சொல்லல, பட் அவங்க ஒரு question கேட்டிருக்காங்க.
Would you like to ask a question now, sir?
Okay, sir. Anyway, the contact details is there in this presentation. They can contact always. They can send to the queries through email, or they can always, you are all welcome to visit our lab.
I'm just trying to
Thank you.
unmute Pramod. 1 second.
Please, sir.
Mr. Pramod, you have been made the co-host also. Kindly check if you can unmute yourself and then speak. Mr. Pramod, please unmute yourself.
Okay.
Yeah, please go ahead.
Thank you, sir. I'm from Tata Motor Pune. So my question is that we are producing passenger car as well as the commercial vehicle also. So this 3D printing can be utilized in the automobile industry also. Specifically, I'm
Yes.
working in pen shop.
Yeah.
It's a vast area in pen shop. So I seen from last 1.5 hour. It is my question. It is possible to introduce in the automobile industry also
Yeah,
for
in
external painting.
So in automotive industry, the different applications are: one, you must be knowing the prototyping area, which they are using for product development. Second, in paint shop, and I think they use it for jigs and fixtures, quick production of jigs and fixtures, which they can use. Third is they use it for spare parts, because as I showed one of my case study, Daimler-Benz has been trying to make digital inventory and trying to work on spare parts. And the last, of course, is making rapid tools, molds for quick production of plastic part or die-casted part. So these are the 4 areas which we know 3D printing has been able to create value to the end consumer.
Okay. Okay. Thank you, sir. Thank you. Thank you.
Raghavan sir, you please go ahead.
First of all, on behalf of Lagu Udyog Bharati and NIKR, we are extremely thankful to Anna University for organizing, I think, one of the best lectures I have heard in the recent times. My special thanks to Mr. Anand, especially the way he went about his presentation. I think the way he showed the Tata, the car and its parts, took me back 32 years into engineering, saying, I still don't know even one part thoroughly well. That is the difference, which is, I think, which he has highlighted, that we need to know. The devil is in the detail is what he reminded me of. And it also gives clarity that if you put things together, I still remember learning FEM in 1988 at PhD, but I've never used it at work. When you look back 32 years, but we had the time, we never used it as an integral opportunity, is what he brought out as very nicely in his presentation. All the things are available. It is the way a system gets together to deliver this process. He talked about speeding this entire technology as an enabler for things than as a technology by itself. I think that was the speciality of this lecture, that it was more a process than a somebody saying, this is a product I have, can you use it? He says, first find a use, then find the process. I think that's an excellent way of putting this idea across. Maybe, I think it's left to our imagination to find out parts which we can use 3D printing. I think that is the challenge all of us have. And as Dr. Arumekannu specialist, and I think the HOD mentioned, we should look at creating opportunities within industry to come back, to go to Anna University to create parts, than to waste time figuring out how to do things. Thanks a lot. I think I once again thank LUB, I think, for just, I keep telling, allowing us to be co-host or members in this entire learning process. Thanks a lot, Hariharan sir, and thanks a lot, Chedian sir.
Thank you, Raghavanji. One more question in chat box. One is Satyapriya from Pesan School in Pondicherry. She is asking how scope in 3D printing can improve fashion industry.
If you Google and see Milan Fashion Week, you can see a lot of fabric being 3D printed the shoes for the fashion industry being 3D printed, accessories 3D printed. So it has unique proposition. Because we don't have time, maybe if Mrs. Satyapriya can send an email, we could forward the case studies for her to appreciate where it can be used.
Even the Black Panther also you can mention. That
Yeah,
Avengers movie Black Panther, that the fashion industry, it's used, all the things will be used by 3D printing.
Yeah. From apparel to
Apparel
shoes
to shoes, yes.
to
Jewelry.
jewelry, accessories,
Yes.
everything.
Everything.
மிக்க நன்றி அருமைக்கண்ணு மேடம். நீங்க உங்களுடைய பேர்லயே வந்து அருமைக்கண்ணுன்னு வச்சிருக்கீங்க. ஓகே, அருமையா இந்த நிகழ்ச்சியை அமைச்சு கொடுத்துருக்கீங்க. ஏன்னா இந்த நிகழ்வுக்கு வந்து நீங்க தான் ஒரு அதிமுக்கியமான நபர்னு சொல்லலாம். ஃபர்ஸ்ட் ஸ்டார்டிங்ல இருந்தே பேசுனதுல இருந்தே ரொம்ப சிறப்பா இந்த நிகழ்ச்சிக்கு வந்து அருமையா அமைச்சு கொடுத்துருக்கீங்க. உங்களுடைய பேர் உங்க பெற்றோர்கள் எப்படி வச்சாங்கன்னு தெரியல, எல்லாத்தையுமே அருமையா அமைச்சு கொடுத்துருக்கீங்க. மிக்க நன்றி. எங்களுடைய இந்த நிகழ்ச்சியை வந்துட்டு ஒருங்கிணைத்த நம்முடைய உமாமையப்பன் ஜியும் இப்ப ஜாயின் பண்ணிட்டாங்க. இன்னைக்கு வந்து அவங்களுடைய மாமனாருக்கு வந்து 80வது பிறந்த நாள். அதனால அவங்க வந்து அந்த பூஜையில இருந்ததுனால இப்பதான் ஜாயின் பண்ணிருக்காங்க. உமாஜி, வெல்கம் யூ ஃபார் திஸ் ஃபார் அரேஞ்சிங் திஸ் ஒண்டர்ஃபுல் செக்ஷன் டுடே. யூ ப்ளீஸ் கோ அட் ஜி, யூ கேன் ஸ்பீக் சம்திங் இன் அவர் டீம்.
தேங்க் யூ ஜி.
முதல்ல உங்க மாமனாருக்கு எங்களுடைய லகு உத்யோக் பாரதி சார்பா வாழ்த்துக்கள்.
ரொம்ப நன்றி. ஆக்சுவலி இப்பதான் ஆயுஷ் ஹோம் எல்லாம் முடிஞ்சது. அந்த கடைசி பூர்ண இந்த இதுக்கு போகணும். அதுக்கு முன்னாடி வந்து செஷன்ல எல்லாருக்கும் ஒரு ஹலோ சொல்லிட்டு ப்ரொஃபசரை ரொம்ப தேங்க் பண்ணிட்டு போகணுங்கிறதுக்காக இப்ப வந்து ஜாயின் பண்ணிட்டேன். ப்ரொஃபசரோட ஹெச்ஓடி இருக்காங்கன்னு நினைக்கிறேன். நன்றி. இந்த மாதிரி நம்ம நிறைய ஸ்கில் டெவலப்மெண்ட்டுக்கு நிறைய ப்ரோக்ராம்ஸ் பண்ணணும். இதை வந்து இப்ப பிசினஸ் ஓனர்ஸ் பார்த்து நம்ம கொஞ்சம் அவேர்னஸ் வந்திருக்கும்னு நினைக்கிறேன். இதுக்கு மேல உங்களுக்கு கேள்விகள் இருந்தா நிச்சயம் ப்ரொஃபஸரும் அவங்க அந்த எக்யூப்மெண்ட் மேனுஃபேக்சரர் கம்பெனி அவங்களும் தே வில் ஹெல்ப் அஸ் டு சார்ட் அவுட். இல்ல என்ன டவுட்ஸ்லாம் இருந்தாலும் இமெயில் பண்ணலாம், அவங்க கிட்ட டவுட்ஸ் கேட்டுக்கலாம். இல்ல என்னன்னா டெக்னாலஜி நம்ம யூஸ் பண்ணணும், நம்மளே வாங்கி வச்சு பண்ணணுங்கிற அவசியம் கிடையாது. பட் ஏதாவது ஒரு விதத்துல டெக்னாலஜி யூஸ் பண்ணா நம்மளுடைய குவாலிட்டியும் இம்ப்ரூவ் ஆகும், கொஞ்சம் வேகமாவும் எல்லா விஷயங்களும் நம்ம பண்ண முடியும். பின்தங்கி இருக்காம இந்தியாவோட எம்எஸ்எம்இ முன்னேறும்னு நான் ரொம்ப நம்பிக்கையோட இருக்கேன். அதைத்தான் ப்ரொஃபஸரும் சொல்லிட்டு இருந்தாங்க. அவங்க ரொம்ப நல்லா எங்களோட இன்டராக்ட் பண்ணி நிறைய விஷயங்கள் எனக்கு முன்னாடியே சொன்னாங்க. ஆக்சுவலி இந்த ப்ரோக்ராமுக்கு வராம இருக்கிறத விட எனக்கு எல்லா விஷயமும் எனக்கு முன்னாடியே எனக்கு ட்ரெயின் பண்ணிட்டாங்க ப்ரொஃபஸர். ரொம்ப தேங்க்ஸ் ஜி. இந்த மாதிரி நிறைய பண்ணணும். அடுத்த லெவலுக்கு வந்து கம்பெனியோட ஆளுங்க நம்ம எம்ப்ளாயிஸை வந்து ஸ்கில் டெவலப்மெண்ட் ப்ரோக்ராம்ஸ்க்கு ஏதாவது நம்ம காலேஜ் ஆஃப் இன்ஜினியரிங் கிண்டியோடைய கான்டாக்ட் வச்சு ஏதாவது பண்ணணும்னு ஆசைப்படுறேன். அதுக்கு செழியன்ஜியும் ஹரிஹரன்ஜி ஜெயக்குமார்ஜி எல்லாம் வழிவகுத்து கொடுக்கணும். சென்னை சாப்டர் மட்டும் இல்லாம எல்யூபி மெம்பர் எல்லா சாப்டர்ல எடுத்தவங்களும் இதை வந்து பயனடையணும்னு ஆசைப்படுறேன். அதுக்காக நான் கோரிக்கையும் விடுக்கிறேன். ரொம்ப தேங்க்யூ. தேங்க்ஸ் எல்லாம்.
கண்டிப்பா உமாஜி, உங்க கோரிக்கை ஏற்கப்படுகிறது. விரைவாக பண்ணிடுவோம், ஒன்றும் பிரச்சனை இல்லை. ஜி நம்ம நிறைவு பெற்றலாமா ஜி? ஹரிஹரன் ஜி.
Sure, Ji, sure.
Yes, sir.
Thank you so much to all. Thank you, madam.
Ji, thank you for the efforts that you have taken to arrange this program. I think really hats off to you. It was really a wonderful program.
Yes.
Thank you.
Thank you.